Hello, I'm JW. Today we have this to have a look at. I've actually got two of them, both the same. These have actually been sent in, and the deal with these is that these are for those lights that you had in the ceiling, little halogen jobs, and both of these are actually failed within a short time of each other. So let's have a look inside and see if we can see what's actually gone wrong. So I've got two of these things. These are made by Osram, and they're the Halotronic actual little converters or transformers. And these are actually a decent make, and apparently it was made in Italy, or made by Osram Italy, I presume it means in Italy. And these were actually, say, a premium item at the time, certainly among the more expensive end. And unfortunately it's another one of these products which has been largely made obsolete, in this case by the prevalence of LED lighting, because these are actually designed for use with the halogen lamps. And here's a typical example of that, 50 watt type of item there, with the two pins on the back. And then, of course, the lamp would just fit into the holder like that, and then it would fit in a particular installation in the ceiling. This, of course, is above the ceiling and converts the 240 volts in to, in this case, 11.5 volts output for the lamp here. And say both of these have failed. Not clear how long these were in service, but probably quite a long time, so they haven't made these for many years. And the letter that comes with this actually states that one of these actually failed, and then replaced that one, and then just a couple of days later the other one failed as well. So two failed in fairly short succession, so we'll have a look inside of that. Now these lamps, they are pretty much obsolete now because they're halogen. They use a huge amount of power for the light output. This one originally would have been a 50 watt, although this is actually a 42, as you can see on the box there. And these are actually sold in the way of energy saving. And of course that's a bit of a lie, because although 42 is less than 50, it's not much less. And just compare, an equivalent LED of similar brightness and size would typically be in the region of 5 watts. So 42, of course, is still far more than it really should be. And these get extremely hot. Another common failure of these is where the actual contacts here basically are damaged by the heat from the lamp, and then you can end up with these actually failing and it doesn't make good contact, although in this case it still fits in there perfectly well, so that's certainly not it, it is the things themselves. And this one, like so many of these that are sold, is actually the wrong style. This is actually a dichroic lamp, meaning that the light comes out of the front here, and the reflector is designed in such a way that all of the heat actually comes out the back. That is exactly what you don't want in a ceiling, because of course you want the heat and things to come out the front to avoid the back overheating. Now this particular box here is a dial brand. These are actually sold by B&Q or the Kingfisher Group. They're not actually listed up as dichroic or other, so of course most people just go to the shop and buy these and end up with the wrong variety. What this should be is an aluminium reflector which is completely opaque, so everything is out the front. But I'll show you this as dichroic, because if you place it on top of here and turn on the light, as you can see, the light pours through the back of it, and that's obviously because of the reflector there, which basically allows some of the light obviously to come most through the front, and then the heat is mainly reflected through the back, being of a longer wavelength. So good job there, B&Q, by mislabeling products and selling them as suitable for ceiling lights, when in fact they couldn't be any less suited. So let's have a look at these, and so at the time these would have been a fairly premium choice, certainly not your everyday cheapo-matic variety. So that would have just gone to the lamp holder there, and then we've got this little cover here for wiring connection. So essentially we've got here the output, in this case is 11.5 volts, and this goes to the 12 watt lamp there, and then the input is, it says there, 230 to 240, 50, 60 hertz. Now the output of these is not DC, it's generally AC, and it's normally at a fairly high frequency, because of course when you're just driving a filament lamp it doesn't actually matter what the frequency is. And if you're going to replace the actual halogen lamps like this with LED, it's not normally worthwhile getting LEDs with the pins on, because a lot of those are not compatible with this type of converter, mainly due to the high frequency. Some are and some will work, but if you've got this style, then the best thing to do is what the person sent it in has done, which essentially ditch these completely and just put whole new LED lights in there, which either have their own converters in or are the mains voltage variety. Now there's no obvious screws here, so we're going to have to basically pry into this somehow. There is a cut line there. This is all one moulded piece, so presumably this part will pop off. So let's just see if we can go in there and pry the thing open. Right, well, it seems the end is just a clipped in type of thing made on the sides there, so that just pops open like that. So just a single piece of fairly bendy plastic on that one. Obvious markings on that, and then the front piece again is just a single piece that just say clips in on the side there and over there. That just goes on with those notches there, so it's basically a one-time assembly deal without obviously having to pry the thing apart. So we'll just remove the wires from those terminals. And so we would expect these to be a decent quality manufacture. There's the two parts there which they just clip together, so in the manufacturing it is literally going to be a question of just shoving it together. Now it just clips together and that's it, basically secured in one piece. So here we've got the two items. This one and this one basically are identical, although this one has that sort of burny type of smell to it, as if it's got rather hot at some point and possibly has damaged something. This one doesn't appear to have that odour, but nevertheless it's fairly likely these have overheated in some way. Another thing that happens with these is people put them in the loft or something above the room, and then they get covered up with insulation and things, and of course get extremely hot and tend to fail. So here's a close-up view of them, and these appear to be made decently well, and that's pretty much what you would expect from a known manufacturer of these things. And I say both these do appear to be pretty much identical. So just the terminals on the one end for the mains input, and then the output there. And if we have a look on the back here, again these do appear to be pretty much substantially the same there. Now we'll notice here on the actual output here, which is actually marked secondary, we've got the extra large track area there, because of course the output current on these is significantly greater than what goes in. So in terms of the voltage, it's dropped down by a factor of 20, but when you've got a 50 watt lamp on only 12 volts, you're going to have 4 plus amps coming out on the 12 volt side. So here's a closer look at the board here, and say as you'd expect from someone like Osram, it's a decent high quality construction there. So we've got the terminals here for the input and output, and they are the decent kind with the rising clamp underneath, so that as you tighten up the screw, it's actually pulling up a flat metal plate to grip the conductor rather than the screw just graunching down and twisting into the copper conductor. And you see they've left a hole in the centre there, also to provide separation between the input and output sides. And note on these, this is actually the transformer here. And notice how big this is compared to some of those cheap Chinesian ones we've seen. It's a pretty substantial item there. And see on the back here we've got this considerable decent space between the output and input sides there. So again, a reasonable amount of effort went into designing this, and it certainly isn't a question of cutting it down to a price. It's also designed up to a specification there. And this one over here is presumably some kind of input filtering thing there, just a choke there, presumably with the two wires either side. Yeah, all those are basically just common together that side, and pretty much the same over that side. A few diodes in the bottom there to act as a bridge rectifier, and then we just got our capacitors mounted on the bits there. So there's not a huge amount of circuitry in this one, but again it's going to have been optimised to a certain extent. Little suppression capacitor on the other side there. Yeah, it's just use case it's between the output here, the secondary there, and the input there, which is again fairly common on the even on the cheap ones. They normally do put that in there. So nothing obviously on the board that's sort of burnt or destroyed or whatever. And on the back here it's basically just the actual solder and the tracks there, and then we have two of these devices at the top here, which are basically soldered down to the board to act as a sort of heatsink arrangement, and then just the two pins coming down onto the tracks on either side. And then the other thing is we've got a few surface mount items here, so just a few resistors there and a couple of capacitors mounted on this side. So interesting construction there. This is all basically through hole stuff from this side, so fairly more traditional type of thing. And then we've also got the odd surface mount thing on this side as well as the two main devices, and again a few more resistors down this end here, and the rest of it is just basically the pins through from the previous side. But certainly the space here between the input and output is certainly way more than it actually needs to be. We've got this huge space say all the way through here. So the only thing linking it is literally just the big transformer there, and then that single suppression capacitor across the 2 pins here. This is the other one, and it's pretty much the same deal, and nothing obvious that appears to be burnt, destroyed, or otherwise failed. And again, the back, again, pretty much the same deal again there, with the 2 devices at the end there, and the odd few resistors and things on the back. Now just check some of the components on here. There's nothing obvious that has actually failed. The transformer there obviously measures through correctly. These on the end here just measure as a pair of diodes. There is actually a tiny little transistor in the middle here. It's difficult to see it sort of right down in there. But again, that measures fine as so again, a pair of diodes essentially. And so there's nothing obvious that's burnt and destroyed. The diodes on the top here all measure as you would expect, so about 0.7 volts in one direction and open in the other. So there's nothing obvious on the board which is either damaged, and everything that can be measured there actually tests out just fine. And the other thing to say, these capacitors don't show as any capacitance, but that's more than likely because they've obviously got other components connected to them. Although of course if one of those has failed, that could be a cause of it not actually working. And a note here that unlike power supplies for most other stuff, there's no smoothing on the output here at all. So I've got the transformer here, and this is the output here, so just these 2 pins I've got here. And essentially this goes straight from the transformer directly to the output, which are the 2 big terminals here. And the only other component on the top is this suppression capacitor between basically one side and then the mains input over here, so basically between there and there. So there's no other components on the output at all, it is literally just direct on the actual transformer. And so it doesn't actually need smoothing, of course, because in the case of this, what you're going to be connecting to it is obviously one of those halogen lamp things. And so these don't obviously care whether it's AC, DC or anything else. And the fact it's a filament lamp, of course, would provide any smoothing that's needed. So in terms of any flicker or whatever, because it's obviously a extremely high temperature there, it's going to smooth out the lighting just as a normal incandescent lamp would at 50 Hz. So no smoothing on the output, and this is also partly why these are not really suitable for driving LEDs, because what's coming out of here is typically in the many kilohertz range. It's not a particularly nice and smooth waveform, it's usually all jaggy and horrendous, so while it's okay with a filament lamp, not the sort of thing that was ever designed for LEDs. And of course, although you may be able to get some LEDs which work, it's fairly likely to shorten their life dramatically. So if you do have any of these, then again, if you change to LEDs, just buy whole new LED fittings. It's cheaper and easier in the long term because you don't have the problems associated with these being completely incompatible. So look at these Osram Halotronic converters, and say these are now pretty much obsolete because of the advent of LED lighting. These are not really suitable for driving LEDs, so although it might work in some cases, generally don't bother. If you're going to go to LED, just buy new LED lights and fit those instead. And these, say, are pretty decently made. Obviously these are fairly old ones, and something is obviously failed in there, though it's not entirely obvious as to what, because all of the main components there do test up as you would expect. But obviously there's some failure gone on in there. So that's it for this time, and until next time, thanks for watching.